Hi, everyone. Let's keep on going in chapter 1. This is the video lecture for section 1.5, solving one-step linear equations. Okay. So other than the word linear, we've talked about equations before. An equation is just a mathematical expression that has an equal sign in there. So here it's an unknown variable x equals 5. So x is just 5. We might also have something like 2x equals 10. Well, that tells us that the x value, or when the x value is 5, this expression will be true. So x equals 5 solves this expression. So a linear equation is just a special type of equation. A linear equation has only x, no other power of x, and only addition, subtraction, and multiplication, which sometimes looks like division. I'll show you what I mean in a minute. So it has addition, subtraction, multiplication, but the division can only be division by numbers. It can't be divided by variables. So I'll give you a couple examples and then I'll write down the general. So I could have something like, well, if I have x equals 5, that's a linear equation because it has only x's. It has no other powers of x. And the only mathematical operations, well, there's nothing other than addition, subtraction, multiplication, or division. There's actually nothing here at all, but that's still a linear equation. 2x equals 10, that's linear because it has only an x, and the only operations, in this case, there's a multiplication. I can have x plus 3 equals 13. This is linear because it only has an x, and the only operation is a plus, is addition. By the way, all three of these equations are equivalent, almost. This one is not. Never mind, these two are the same, but this one is not. And a slightly more complicated one could be something like 7x minus 2 equals negative 24. Now it's linear because it has only x's. There are no other powers of x, and it only has addition, subtraction, multiplication, or division. There's a multiplication and there's a subtraction. Some non-linear equations would look something like if I took x squared plus 3 equals 15. Notice that this is not an only x. This is the second power of x, so it is non-linear. It's true that the only other mathematical operation is a plus, but since there are powers of x that aren't just plain old x, it can't be a linear equation. I'll show you a couple more. Non-linear ones. And then I'll show you some that don't look linear, but actually are. Because those ones, as you might think, are the more challenging ones. So another nonlinear equation might be something like x minus y equals 4. Again, in this case, it's not a linear equation, at least not in a single variable, because there's an x and a y. So we can't solve it just by figuring out what x is, because the y also depends. Or I could have something like x plus 1, but if I put it under a square root, it's not linear because the square root is a mathematical operation. So this has a power of x. This is more than one variable. And this has a mathematical operation that is not just addition, subtraction, multiplication, or division. So these are all nonlinear equations. So linear equations that don't look linear at first glance. I could have something like 3x plus 1 equals 12x minus 8. It's a little bit more complicated, but again, the only x's are just x's by themselves. There's no powers of x. And the only mathematical operations are multiplication, addition, and subtraction in this case. So this may not look linear, but it is linear because it meets those criteria. Here's another one that may not look linear. I could have x minus 3 divided by 2 equals 5x. All right, I'm seeing this division sign, and that makes it look like a more complicated mathematical operation. But I still only have x's. I have a subtraction and a multiplication and a division by a number. And that's important. If you divide by just a number, then it is linear because I could rewrite this. Dividing by 2 is the same thing as multiplying by 1/2. These two expressions and equations are equivalent, and this one is multiplication. And that's why when I was writing down my list of criteria, I put division in the parentheses because the type of division that we allow is just a different kind of multiplication by a number. And there's one more nonlinear that I'll mention right now. And it looks something like x plus 2 divided by x equals 4. This is nonlinear because that x is doing the dividing. And you can't do division by x in a linear equation. You can only do division by numbers in a linear equation. So those are some examples of linear equations. The general form, and the one that's given in your worksheet, the general form of a linear equation is one variable, and that variable is going to be x, is let A, B, and C all be fixed numbers called constants. I might not know what those numbers are, but I know they're never going to change. Also, A can't be 0. If A is 0, then we're dealing with something else. So A, B, and C are all fixed numbers. The relationship A times X plus B equals C is the general linear equation. So as an example, if A equals 2, B equals -1, and C equals 10, then I would have 2x minus 1 equals 10. And this looks familiar. It looks kind of like some of the equations on the previous page. If A equals, let's say, -1/3, B equals 5, and C equals 0, then I could have -1/3 x plus 5 equals 0, right? And there, even though I have a multiplication by a fraction, I could think of it as minus x/3 plus 5 equals 0, right? So I can think of it as a multiplication by a fraction less than 1, or I can think of it as a division. And what would happen if A is 0? If A equals 0, then I would have 0 times x plus b equals c, but 0 times x goes away. And now there isn't an x, so it's not a linear equation. It is not an equation. So that's our general linear equation, a times x plus b equals c. In previous videos, I've actually been solving linear equations, mostly to demonstrate how we write down our mathematics. So what you're going to see here is actually going to be more of a review of what we've already done. So solving linear equations, let's say when a equals 1. So linear equations when a equals 1 would be things like x minus 8 equals 2. Here a is 1, b is -8, and c is 2. And as I showed you before, to solve that, we want to get all the x's on one side and all the numbers on another. So let's add 8 to both sides, and we have that x equals 10, and we're done. We now know when x is 10, this linear equation is true. Or it could be something like x plus 13 equals 8. And so we'll get all the variables on one side and the numbers on the other. So this time, if we subtract 13 from both sides, that's going to cancel out the 13 and the minus 13, just leaving an x, and an 8 minus 13 is -5. And again, we're done. We don't have to work with whole numbers. I can have something like x plus 1.2 equals 3.7. Still just subtract the 1.2 from both sides. Those will cancel, and that gives me x. And here, again, you're welcome to use your calculator, but let's do this by hand. 0.7 minus 0.2 gives me a 0.5, and 3 minus 1 gives me a 2, so x equals 2.5, and we're done. Or I could have some kind of fractions, like 7/10 equals x minus 2/5. Expressions or equations don't have to have the x on the left side. They can have the x on the right side. Nothing wrong with that. Again, let's get all the numbers on one side. So let's add 2/5 to both sides. And we get 7/10 plus 2/5 equals x. We have now figured out what x is in terms of a number, but for me, I can't look at a number and have a sense of how big it is because it's written two fractions added together. Couple ways to approach this. You can grab your calculator and add those together and it'll give you a decimal, or you can convert them to a decimal and then add them together, or you can use addition of fractions to get them together. The whole point of combining these numbers and maybe getting a decimal is so we know generally how big the number is. So I'm going to do this one by hand. I know 7/10, 2/5. If I want to think of that as 2 out of 5, that's the same as 4 out of 10. So now I'm adding 7 out of 10 with 4 out of 10. 7/10 of a pizza plus 4/10 of a pizza gives me 1 pizza plus a little extra, gives me 11/10 of a pizza. And now we're done. And alternatively, if we had converted, we would have a 0.7 plus 0.4 because 2 divided by 5 equals 0.4. And then when we add those, we get 1.1 equals x. Those are the same number there. All right, that's when the a is a 1 and the x is just always by itself. The other single step linear equation is when the b is a 0. Now, suppose we're going to let a be any non-zero number, and b is going to equal 0. This is going to give us something like 2x equals 10. Right? Here a is 2, b is 0, and c is 10. And to solve this, we say, well, if 2x is equal to 10, then if I divide both sides by 2, that tells me that x is equal to 5. And just for fun, I'm going to do a visual approach to this using my blocks here. I'm going to draw out 10 blocks. I'm going to conveniently group them into groups of 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 of my x's is going to give me 10 blocks, which means 1 of my x's is going to give me 5 blocks. Visual representation of mathematics does not just mean graphs on a Cartesian plane, graphs on an XY plane. It can be a picture like this. It can be a drawing. Really anything that helps you understand the mathematical ideas visually is great. All right, let's do another example. Let's look at 1/3 x equals -4. All right, so in this case, a is 1/3, b is 0, and c is -4. So I can write it this way. I could also think of writing it as x divided by 3 equals -4. And if I want to cancel a division, I can multiply both sides by 3. 3 on the top cancels with 3 on the bottom, and that gives me x. -4 times 3 gives me -12, and I'm done. And if we want to think about it visually, let's see. So all of this big rectangle is x, and 1/3 of it is going to be 4 negative. It's hard to draw a negative, so we just think of this as negative. So if 1/3 of the whole thing is -4, then all of the whole thing has to be -4 and -4 and -4, which is -12. I have a cat. You probably just heard her. She's gonna meow sometimes. All right. I like to use x. X is the most common variable. I said that in an earlier video, but it doesn't have to be. I'll probably always use x. Maybe once in a while I'll use t. in a general equation, but pretty much if it's not linked to a word question, I'm just going to use the variable x because I like to keep it simple. But I just want to let you know that on web work, on your worksheets, you may be asked to solve something like 1.8z equals 14.5. And we have to find the z that makes it true. Now, how I would approach this is I would do the math on paper. I would say, okay, if 1.8z equals 14.5, then I'd want to divide both sides by 1.8. And that gets me z is 14.5 over 1.8. I don't know how big that is, more or less, but my calculator sure does. So I'd hop over and I grab my calculator, which I'm doing off screen right now, and I just do 14.5 divided by 1.8, and I get 8.055 repeating forever. So calculators are handy, nothing wrong with using a calculator. All right. Word questions involving linear equations. Well, if you've ever calculated a tip, you've basically done a type of this, an applied question involving a linear equation. So your friends and you, I'm not going to write all this down, but your friends and you go out to dinner, and your dinner bill is $86.32. How much is a 20% tip, right? That might be the first question. And for this, let's try to write this. So this is a verbal representation of a mathematical idea, and let's write it as a numerical representation. I want to take my 86.32, 20% of that is like multiplying it by 0.2, and that's going to be the tip, which I'm going to write as x. So this is not actually an equation that we're solving. This is a mathematical expression that we are going to evaluate. 20% of 86.32. I'm going to grab my calculator for this. Is 17.26 approximately. 264 equals x. Which brings up a good point actually. If you're leaving a tip, there's no such thing as $17.26.4. But most of us would round. And to be honest, most of us would probably round it even a little bit more. 17 sounds good. Or we might round it up and go 18 instead of 17. So as soon as we step out of the pure mathematics world, like here's a pure mathematics question. Z equals 8.05555 repeating forever. That's a good answer in a pure mathematics world. But now that we're in an applied world, whereas we're using math to answer actual questions, 17.264 doesn't make any sense. No pun intended. So I would probably say, how much is a 20% tip? Round it up to the nearest dollar. And I would say, okay, $18. Now suppose that your friend only has a $10 bill for the tip. Let's pretend we exist in a world where we don't all have Cash Pay and Apple Pay and Google Pay. Is that a fair amount to tip, right? By the way, that's probably the question that you would ask. Is it fair to only leave $10? Mathematically, we're saying what percent is that tip? And is that percent fair? So part of your job as a mathematician is to convert questions people actually ask. Is $10 a fair amount to tip on an $86 dinner? To convert that to a mathematical question that you can solve. So what we're really asking is, I have an $86 and 86.32 bill. I'm gonna use another variable so I don't get the X and the Y confused. And the X is confused. And I'm gonna apply my tip percentage, and I'm gonna get $10. So Z is the tip percentage. How do we know if Z is fair or not? Well, we need to find out what Z is. So now we're solving a linear equation for Z. We solve it by dividing both sides by 86.32. And then grabbing our calculator because I don't know that number off the top of my head. 10 divided by 86.32 is 0.11.11584, et cetera, et cetera, et cetera. But remember, we're working in the real world, and I would look at that and I'd say about 11% tip. Whether or not you think that's fair, that's your decision, but it certainly is a lot smaller than a 20% tip. So maybe you all decide to chip in a little bit more. So that's an example of a word question involving a one-step linear equation, and that brings us to the end of this video. Next video, we'll look into linear equalities instead of linear equations. Thanks for watching.